Alright, so we have already done this chapter, physical quantities and measurement. So the first part we have already completed, that is measurement. So what is measurement and everything we have discussed in the first part. Now let us talk about physical quantities. So what do you understand by physical quantities? So physical quantities, anything that can be measured. Okay, so for example, rice, wheat, potato, anything that you measure, cloth, for example, speed of a car, that is a thing that you can measure. So things that you can measure is physical quantities. Now quantities which can be measured. Now what are the quantities which we cannot measure? The quantities like love, emotion, those are some quantities which we cannot measure. Alright. Now here the examples are few quantities over here. For example, rice, milk, as we discussed, cloth are the examples of physical quantities. Alright. Now whenever you go to a grocery, okay, there is very important information that you give relating to physical quantity or units, okay, which you might not even realize. For example, when you go to a grocer, you ask him, say for example sugar, he'll ask you how much. Okay, you say that I want sugar, he'll say how much sugar you want. So you give him two very important information to him. You give him a number, for example 2 kg, so you give him number 2, and kg, that is a unit. So unknowingly or knowingly, you give him information about the unit. All right, so that's why it is important to study units. All right, now physical quantities are classified in two ways. One is fundamental quantities, the other one is derived quantities. So fundamental quantities are basically quantities which do not depend upon any other quantities for their measurements. So basically we studied about the SI units. Okay, so there were 7 fundamental quantities that were written around it. Okay, so those 7 are fundamental quantities. From those 7 quantities, we derived what is called as derived quantities. All right, so derived quantities are nothing but physical quantities which depends for its measurement on fundamental quantities. All right, now these are the examples of fundamental quantities. So there are 7, but we'll be studying only 3. Earlier, temperature was also there in the syllabus. However, due to COVID, it has been removed. So we'll be studying length, mass, time. Okay. So these, to measure a length, you just need meter. Okay. So you don't depend upon any other quantity. So these are the fundamental quantities: length, mass, and time. Now let us also see what are derived quantities. So derived quantities, for example, area, volume, speed, and density. So area, okay, so whenever you take an area, a surface that has been covered by an object, for example, this is a rectangle or a square. Okay, so you have length into breadth. So basically distance between 2 points, from this point to this point you will say length, and from this point to this point you will say breadth. You're measuring the length on both the sides actually. So both the quantities you will write in, suppose this is in meter, say this is 1 or 2 meters. So 2 meters, this is also 2 meter, in that case it will be a square. So 2 meter into 2 meter, so your answer that will be coming is 2 to the 4 meter square. Alright, so this quantity area, it depends upon length, that is the fundamental quantity. Okay, so 2 length, okay, twice you multiply length to get the unit for area, that is meter square. Similarly for volume, you have one more quantity, that is height. Okay, so one more quantity you measure. So volume is nothing but length into breadth into height. So here length is also calculated in meter, breadth in meter, and height in meter. Hence the unit comes to meter cube. Similarly, speed, it is derived from distance upon time. The formula for speed is distance you traveled upon time you took. Okay, so distance you traveled would be in meters and time is in seconds. Hence, its unit is meter per second. In the same way, density is mass upon volume. Mass, we know it has been calculated in kilograms, so it is kg, and volume we know it is meter cube, so it is kilogram per meter cube. Now this is how from fundamental quantities, these quantities and their units have been derived. Alright, so there are only 7 fundamental quantities, okay, and there are n number of derived quantities. Okay, now these fundamental quantities, they have, or these SI units, so all derived or fundamental, they have prefixes. Okay, so why we need prefixes? Prefix, will just understand it. Okay, so prefixes are of two types. Prefix means that something that has been written in front of it. Okay, so they are of two types. One are the multiples, the other one is submultiple. Multiple means it is a multiple of it. Submultiple is it is divided. Okay, it is less. So we'll understand with examples. Suppose we have to measure distance from a pole to equator. Now this distance, the SI unit distance is meter, but it is not convenient, or the number of zeros would increase. Okay, so we use a better way of measuring. So we use mile or kilometers. So basically we use kilometers. So it is around 10,000 kilometers from pole to equator. All right, so this becomes a multiple. Okay, so when we write it, okay, we write it as kilometer. So here you see the unit is meter, and before that you write kilo, hence it becomes a prefix, and it is a multiple because it is a multiple of meter. So you know 1 kilometer is equal to 1000 meters. Okay, so it is a multiple of it. Now, if there are some smaller things, for example, coin, you don't need a meter. Meter is like 100 centimeters. Now, this is a distance is hardly 2 centimeters. All right. So you need a submultiple. Okay. So even there you have a prefix, hence a submultiple prefix, that is cent. So you say centimeter. All right. Similarly, you have millimeter. All right. So here again, so if you want to measure the diameter or the thickness of the coin, if you have to measure, suppose in that case it will be very small, it will be in millimeters. Okay, right, so these are the basic understanding of multiples and submultiples. Now convention, how to write these units. So there are certain rules that you need to follow while writing these units. So first one, so symbols used, so there are name of the scientists that have been given to certain units. For example, the unit of force, you say Newton. So whenever you're writing Newton, it will be an uppercase or a capital letter. Okay. Whenever you're writing only the abbreviation, that is only the short form of it, you'll write in capital letters or in uppercase. The other example would be a Kelvin, okay, Celsius, or the scientist names. Wherever there is a name of a scientist, in that case Joule, in that case you will write capital letter. Okay, and whenever you're writing a unit, okay, whenever you're writing the entire name of that person, when you're representing it as a unit, so suppose you are writing 10 Newton, instead of writing 10 Newton, the abbreviation, you're writing the entire thing 10 Newton. In that case you will always use a lowercase, that is a smaller letter. All right, so again we'll come to it. So the first one is you use a capital letter. Now symbol used to write anything other than the name of the scientist is always in lowercase. So suppose you are writing kilogram, so it will be in lowercase. You are writing gram, it will be in lowercase. You are writing meter, it will be in lowercase. All right. The third one, again, unit names after scientist when expressed in words. So here I gave you the example over here. If you're writing the Newton, the entire word you are writing, in that case it will be in lower letters. All right, so you will write it in lowercase. Okay, unit in words is always in lowercase. So even if you're writing kilogram, it will be in lowercase. So in other units, so meter, you're writing meter would be always in lowercase. Okay, you won't write capital M or you won't write a capital K. All right, so it will be always in smaller case. It doesn't matter if you're writing the entire name or you're just writing the abbreviation of it. All right. Okay, the other important thing we make mistakes while writing this is, for example, kg. What is your weight? So if you say 50 kg, it will be kg. It will never be kgs. Okay, so this is wrong. All right. So whenever you're writing, it will be 50 kg. Okay. So it is never in a plural form. It is always singular. So 500 meter, not meters. Okay. Okay. Or 10 kilometer or 10 kilometer. Okay. It will be not meters. So it is always in singular form. Space is left between two symbols used as product. So sometimes some units, say for example Newton meter, so you'll leave a space in between. All right. So when you're writing two units, so for example in densities was kilogram per meter cube. Now here it is not a multiple, it is dividing it. But when you are writing a product, for example Newton meter, in that case you will leave a space in between. Okay. All right. That's it. Thank you so much. Bye.